Imagine a planet about the size of Earth, moving through the Milky Way completely alone. There is no sun in its sky, no sunrise, no familiar star marking the passage of a day. The surface may be buried beneath ice, surrounded by darkness that never ends. From Earth, this planet would be almost impossible to see. It does not cross in front of a nearby star. It reflects almost no light, and it may drift between the stars for billions of years without revealing that it exists. Astronomers call it a rogue planet, a world with no permanent home, traveling through the galaxy on its own. For years, scientists believed these lost worlds were rare, but a growing collection of strange signals has suggested something far more astonishing. The Milky Way may contain billions, perhaps even trillions of rogue planets. There could be more hidden worlds than stars. But how do astronomers find a planet that produces almost no light? The answer begins with a distant star and a sudden flash that should not be there. Rogue planets do not all begin their lives alone. Many may have once belonged to ordinary solar systems. They formed around young stars, alongside other planets, moons, asteroids, and clouds of debris. But young solar systems can be violent places. New planets pull on one another with gravity. Their orbits shift. Some move closer to their star. Others are thrown farther away. A close encounter with a giant planet can change everything. If a smaller world passes too near, the giant planet can act like a gravitational slingshot. The smaller planet gains speed. Its orbit stretches outward, and if it moves fast enough, the gravity of its star can no longer hold it. The planet escapes. What was once part of a solar system becomes a world without one. It may carry evidence of its past with it, a frozen atmosphere, a moon still locked in orbit, or heat trapped deep beneath its surface, but not every rogue planet must have been expelled. Some may have formed alone, when small clouds of gas and dust collapsed in deep space without creating a true star. That means the galaxy may contain two kinds of lost worlds: planets that were forced from their homes, and worlds that may never have had a home at all. A rogue planet gives off almost no light, so astronomers cannot search for it the way they search for ordinary planets. Instead, they watch distant stars, millions of them. Most remain steady, but every so often, one star suddenly becomes brighter, not because the star has changed, and not because anything has exploded. Something invisible has passed between the star and Earth. The gravity of that hidden object bends the star's light. For a brief moment, it acts like a natural magnifying glass. The distant star appears brighter. Then the alignment ends. The light returns to normal, and the invisible object disappears back into the darkness. This effect is called gravitational microlensing. The shorter the flash, the smaller the hidden object may be. A massive object can brighten a star for days or weeks, but a small rogue planet may reveal itself for only a few hours. Some signals may last even less than that. Astronomers must be watching the right star at exactly the right moment, because once the planet moves on, they may never see it again. There is no glowing trail to follow, no orbit to measure, only one brief pulse of light, a tiny clue that an unseen world just crossed our line of sight. And when astronomers began collecting more of these strange signals, the estimated number of lost worlds started to rise. At first, astronomers expected rogue planets to be unusual. A few giant worlds might be thrown from unstable solar systems, but the number should have been small. Then the signals began to tell a different story. Microlensing surveys started finding brief flashes that could not be explained by stars or giant planets. Some signals lasted a few days, others disappeared after only a few hours. The shorter the event, the smaller the hidden object could be. That suggested the galaxy was not filled only with giant rogue planets. Smaller worlds might be far more common. Earth-sized planets, frozen super-Earths, and perhaps objects even smaller than our own planet. In 2023, one major analysis reached an extraordinary estimate. There could be roughly 20 rogue planets for every star in the Milky Way. If that estimate is correct, the total number could reach into the trillions. More planets wandering alone than planets orbiting stars. But this is not a final count. These worlds are difficult to detect, the signals are rare, the events are brief, and some candidates may still be planets traveling on extremely wide orbits around distant stars. Scientists are working with limited clues, yet even the lower estimates point to an enormous hidden population. The largest group of planets in our galaxy may be the one we understand the least. When most people imagine a rogue planet, they picture a giant frozen world. Something like Jupiter, drifting through space without a star. But the hidden population may be much more varied. Some rogue planets could be massive gas giants. Others may be frozen versions of Neptune. Many could be rocky worlds closer in size to Earth. And some may be even smaller. The evidence suggests that smaller rogue planets could be more common than giant ones. That means the galaxy may be filled with lost worlds of every kind. Some may have thick atmospheres. Some may still have moons. Others may be covered in ice from pole to pole. A planet that was thrown from a young solar system might carry traces of its old life with it. A moon still trapped by gravity, heat buried deep inside, or an atmosphere slowly changing in the darkness. Other rogue planets may never have orbited a star at all. They may have formed alone from collapsing clouds of gas and dust. Two worlds could look almost identical from a distance, yet have completely different histories. One may be an orphan. The other may have been born in the dark, and somewhere among this hidden population could be worlds unlike anything we have ever seen. A rogue planet may appear completely frozen. Without sunlight, its surface temperature could fall far below anything found on Earth. Oceans would freeze, the atmosphere might collapse, and the entire world could seem lifeless. But a frozen surface does not always mean a frozen planet. Deep inside, heat can survive. Some of that heat may remain from the planet's formation. More can come from radioactive elements slowly breaking apart within its rocky interior. If the planet has a thick layer of ice, that ice could act as insulation. Beneath it, liquid water might remain trapped for billions of years. A dense atmosphere could also help. Under the right conditions, a thick blanket of hydrogen might hold heat close to the surface, even without a nearby star. Scientists have not found an ocean on a rogue planet. They have not found life there, but the laws of physics do not rule out the possibility. A world drifting through endless darkness could still contain warmth beneath its frozen shell. It could have moving water, chemical energy, and perhaps environments where life might survive without ever seeing sunlight. Somewhere between the stars, a planet with no sunrise may still have an ocean hidden below. For now, astronomers have only caught brief glimpses of the rogue planet population. Each signal is rare, each event is temporary, and many disappear before scientists can study them in detail. But a new generation of telescopes may change that. The Nancy Grace Roman Space Telescope is designed to watch enormous fields of stars near the center of the Milky Way. Instead of studying one star at a time, it will monitor millions. It will search for the sudden brightening caused when an unseen object bends the light of a distant star. Some events may last for days, others may last only hours. The shortest flashes could reveal planets close to the size of Earth. Roman will not photograph every rogue planet directly. Most will remain too dark and too distant, but it may collect enough signals to show how common these worlds really are. Scientists could begin comparing their sizes, estimating how many exist, and testing how often young solar systems throw planets into deep space. The telescope may even help answer one of the biggest questions in this story. Are there truly more rogue planets than stars? For centuries, the galaxy has appeared to be defined by the stars we can see. Roman may reveal that much of it belongs to the worlds we cannot. The stars we see are only the visible part of the Milky Way. Between them may drift an enormous hidden population of planets. Some were thrown from young solar systems during violent encounters. Others may have formed alone, without ever belonging to a star. Most will remain invisible. They will produce no sunrise, no reflected glow, no clear path for astronomers to follow. Yet for one brief moment, a lost world may cross in front of a distant star. Its gravity bends the light. The star becomes brighter, and an unseen planet reveals that it was there. If current estimates are correct, these events are not exposing a few rare objects. They are offering tiny glimpses of a population that may number in the trillions. The Milky Way may not simply be a galaxy filled with stars. It may be a dark ocean filled with lost worlds. Worlds carrying frozen atmospheres, hidden moons, buried heat, and perhaps oceans sealed beneath miles of ice. Most will travel through the galaxy without ever being discovered. But every so often, one crosses a distant beam of light and briefly steps out of the darkness. This is Hidden Science Stories HQ.